Hi everyone, this is Bert from Percussa. So a couple of people have been asking for sort of a video walkthrough of how the mSSP works. So I'm going to try to do that in this video. So I'll first start with giving a hardware overview of the mSSP. And then I will go through some presets that I made here for the mSSP, a couple of simple presets. And then I'll also show you the structure of the presets on the big SSP over here, which is in my rack. And I'm going to do that because the software editor for the mSSP that we're going to ship with it, which works on Mac and Windows and which lets you build patches, is not finished yet. So I've created all the patches on the big SSP and copied them onto the mSSP. So we'll be working with that. So first of all, so the mSSP has 8 inputs and 4 outputs, and you can use the inputs and the outputs any way you want in the patcher grid. So you can use them to modulate modules. You can use them to sample audio. You can do whatever you want with them, and the inputs and the outputs are all DC coupled, and they work for CV signals and audio signals. Triggers, whatever, doesn't matter. So the mSSP also has 2 USB ports. So this is a high-speed port, and this is like a normal full-speed port. And the high-speed port is a port that you'd use if you're a developer or you want to create patches on your computer. Then you connect a USB Ethernet adapter to it, similarly to this right here. And you connect the mSSP to your network, and then you start the editor on your Mac or PC, and you can edit patches that way. The other port is for MIDI controllers, so you can like plug in a keyboard and play some of the polyphonic patches with that. Then the mSSP, of course, has a display. It's a high-quality IPS display, which means it's visible from any angle. And then you have 8 soft keys here. And so these 2 keys give you the global page where you can switch patches. And then you have a module page where you can step through different modules. So for example, an LFO or an output module or input module, macro module, that kind of thing. So you have only these 2 pages. And then you have 4 cursor keys. So these 4 buttons. And actually we're going to be making those red, so it will be more visible and like immediately clear that those are the cursor keys. And then you have a previous module key and a next module key, which you use to step through the modules in the patch, basically. And so the cursor keys are used for stepping through parameter pages. So for example, if you go to the module page and you find like this LFO, then you can use those cursor keys to go to the previous and the next parameter page. This module right here, the LFO, actually doesn't have multiple pages. It only has 1 page. And then the up and the down keys are used to switch the encoders to alternate parameters. So you always have 8 parameters per page. And by pressing up or down, you can see the other parameters on the page. So, but again, this LFO only has 4 parameters actually. So there is a coarse frequency and a fine frequency setting, and then there's a ratio setting and a detune setting. So those are the 4 parameters of the LFO. And when you stop touching the encoders, you will see the scope again of the LFO. And so you have scopes in many places in the modules. Most modules have some scopes or some visualization. Some of them don't have anything yet. So for example, you have the input and the output module with the scopes. And then you have the macro module, which maps global macro parameters to like the modules in the patches. So with the macro, you can like adjust 2 settings at the same time in a patch, for example. So that's kind of how the basic concept of how the mSSP works. So every patch is basically, a collection of modules patched together, and you can switch patches like this, up and down. So the mSSP has push encoders, and so in some of the modules you have toggle settings, and you can activate those toggles using the push encoders, basically. Okay, so I have, to start with, I have a very simple preset called 2. And the preset is just a preset with 2 oscillators, sine wave oscillators. And one oscillator goes to their left channel, the other oscillator goes to the right channel. And you can adjust the pitch of the 2 oscillators simultaneously using a macro control. So, the mSSP has already loaded the patch when it booted up. It always loads the first patch when it starts up. The same with the big SSP. So I'll plug in these 2 cables, and you can hear like the faint sine waves in the background. When you go to the next page here, you can see the macro controls M1 to 4, or if you press up, you see M5 to 8. I will add some visualizations here later on, but right now when you turn the macro control, you have this pop-up visualization. And so when you turn it, you can hear the frequency of the sine wave change. So the macro controls are bipolar between -1 and +1. And so you can map them in the patcher grid to control anything. So for example, a macro could control the frequency of a sine wave, but it could also change the attack of an envelope or whatever at the same time. And of course, you can also process these macro signals in the patcher grid. So you can actually make like a DC signal out of it and then feed it through a module and then to another module and so on. So I'll show you the patch on the big SSP. So I have the same patch here, and the big SSP has a network page where you can patch everything. And you can see here I have the 2 LFOs, and I have the output module, I have an input module. So the output and the input modules give you access to all the jacks, also on the mSSP. And then here you have the macro module, which is linked to the macro controls, like you have the same macro controls on the big SSP and the mSSP, basically. So the way the patching works on the big SSP, and the way it will also work in the Mac and the Windows editor, is that you put modules in the grid. So on the big SSP you have a module chooser, so you just press this and you can add a module from the grid, like you can add an LFO, for example. And now I have this LFO and I can patch it to another module, like let's say the output, for example. And the way you do it is in 2 steps. You first connect the modules together, and then you enable the inputs and the outputs of the modules. And then the software will automatically patch based on which inputs and outputs you enabled. So, so the way this works on the big SSP is you have 2 keys to select the left hand side or the right hand side of the patcher matrix. And the patcher matrix is actually quite big. It has, if you go left here, you are at the end, you have 16 pages of 8 cells. So that's quite a lot of space to put modules into. So anyway, so I'll patch the LFO to the output. So you go to the LFO, you hold this because the output is in the left hand side. And then you press this button, and now there is a blue rectangle around the output indicating that the LFO and the output is now connected. And at any time in the patcher grid, you can see the outgoing and the ingoing connections. So now you have to enable the outputs of the LFO and which ones will send a signal to the output module. So for example, you enable the sine output, and then here I have already enabled for the output module all its inputs, its virtual inputs. So the output module will take up to 8 signals in here on the big SSP, because the big SSP has 8 outputs, and it will send those signals to the physical jacks. So I have patched this sine wave to the output, and you can see the incoming or outgoing connections like this. So now I see all the outgoing connections. So if I go here, I see all the outgoing connections. If I want to see all the incoming connections, I press this button and I go here. So With the Mac and the Windows editor, obviously you will not have to use so many key combinations because you can use your mouse and a keyboard. On the big SSP, you have to work with these buttons. You don't have a mouse and a keyboard, but it's quite fast as well. And you can copy modules pretty easily like this. You do copy, you can go like that. Now you have 4 LFOs. Anyway, so this patch is running on the mSSP. Over here, exactly the same patch. And yeah, that's pretty much it. You'll be able to do everything I did here in the editor from your Mac or Windows computer over your network. You just connect your mSSP to your network and via USB, and you know, the software will find the mSSP on your network and it will call up the patch, will show you the patch physically on your screen, and you'll be able to enable all the inputs and the outputs, and you'll also be able to tweak the parameters. So you'll be able to go to the module, go here to the page where you can see all the module details, and with your mouse you would be able to change this parameter, and it would like real-time update on the mSSP basically. So while the patch is running here on mSSP, I want to say something about the input module as well. So I have an input module in the grid, and the input module is connected to the LFOs, so it can amplitude modulate the LFOs basically. And in the input modules, I have scopes as well. So you can see all the inputs like this. So I have 16 inputs on the big SSP. I can step through them like that. And when I take a cable and I plug in, let's say this STO, now you can see the signal from the STO here, and like when I increase the frequency, you will see it on the scope. So, and then you can enable that signal to come out of the input module. So you can actually sum and route signals inside this input module before the signals come out of the input module, if that makes sense. So I've enabled this scope. Now, here in the grid, I can see the signal here on the right hand side as well, and it's going to the LFO amplitude modulation inputs. And you can see the result of that modulation over here on the scope coming out of it. And you have the same kind of scopes on the mSSP as well. So if you go to the module page, you go to the LFO, you'll see here the scope for these LFOs. Now the signal amplitude is still pretty low here on the mSSP because I haven't connected anything to this first modulation input. Whereas here I have. So what we'll do is we'll take this signal from the STO and we'll patch it into the first input. Now you can see it's a lot louder. You can go to the global page here and play with the frequency. So there you go. So now that we looked at a simple preset, we're going to go to a slightly more complicated preset, which is a granular preset. It's still pretty simple, so I will call up the preset here on the big SSP and then also on the small SSP, on the mSSP. So here I go and I loaded the granular. Here you press the encoder to go to the next preset. And then basically we'll take a look at the network grid, where you can see I have an output module and I have the granular and I have two LFOs. And so the two LFOs are modulating parameters of the granular. So you can see here on the right hand side the LFO is sending a sine wave to the start position of the granular very slowly. The frequency is very low. And then you have another LFO that is also modulating the start position. using a square wave, as you can see. So here you can see the effect of the modulation. So this red window is the grain selection window, from where the grains are picked from the file. And so you have lots of different controls here for the granular. I won't go into all the details, but you have all the normal granular parameters like grain duration, number of grains, you know, start and length of the window, the trigger frequency for the grains. You have the tuning, a dub parameter for overdubbing. You have a blend parameter for a dry-wet mix. You have panning control, you have randomization of the panning, randomization of the start and the duration of the grains, and so on. And of course you can also use live input for the granular, and you can stop and start the recording, and you can even stop and start the recording using a signal. So if you are interested in the granular, look at one of the demo videos that I recorded where I had used a live input. So we're going to call up the exact same patch on the mSSP. In fact, we already did that over here. And you're already listening to it, in fact. And so there is no macro controls in this granular patch, but I'm going to show you how you can play with the parameters of the different modules. So for example, here in the granular, I can change the grain trigger frequency like this. Now it's 0, now it's 20 Hertz. We can play with the grain duration. Like this. Now you have a choir sample. We are back in the granular. And so you'll see that there is two colors on the display. So it displays the channels of the file using different colors overlaid. So you see the left and the right channel there. So then of course, if you want to play with the frequency of the LFOs that are modulating the granular, you can just go to the next module. And here you can fine tune the LFO. Now it's even slower. You can like it for quicker, really quick, whatever. So yeah, let's go into the next LFO, the other one which is providing the sine wave. It's the same thing. You can speed it up, slow it down, whatever. So yeah, so that's kind of how this granular patch works. So you actually don't have to go through all these modules, and you don't have to touch any of the parameters if you don't want to. You could just as well just load up your patch here and use the macro controls, and yeah, you don't have to mess with the module details if you don't want to. So we'll be providing about 50 patches with the mSSP, and the patches will have macro controls and will have pre-made jack mappings, so you don't have to really patch anything. You know, that's the whole point of the mSSP, to load up the patches and to use them. And then if you really want to patch, you can use the Mac and the Windows editor, and you can edit everything to your heart's content, just like you can on the big SSP over here. Okay, so now we're going to take a look at the next patch, which is an envelope follower patch that I built on the big SSP. And again, you can build any patch you want using the Mac and the Windows editor that we're going to provide with the mSSP, just like you can on the big SSP. So we're still on the granular patch. I'm going to go to the next patch, which is this envelope follower patch that I created. So I'm on the global page here of the mSSP. I just press next preset. Now I have the envelope follower patch. And same thing, I will go on the big SSP and go to the envelope follower patch so I can explain it. So basically, in this patch you have a sampler which is playing back a drum loop, and then you have the envelope follower module which takes the input from the sample and creates an envelope from it. Then this envelope is used to modulate the cutoff frequency of this analog model state variable filter. And the oscillator here, it says LFO, but it's really an audio rate oscillator, you know, that can do any frequency. I mean, I have to change the name of the module into an oscillator or something. It's called LFO right now, it's like a historical thing, whatever. It will change. So it's just a normal oscillator with sine wave output, sawtooth output, square wave output, triangle output, and then also all the inverted versions of those waveforms. So with one module you actually have 4 waveforms simultaneously and the inverted versions of it. So I have a signal going from the oscillator into the filter. I'm using a sawtooth. You can see it on the scope. And here you see the envelope from the envelope follower and the output of the filter and so on. And then the filter goes to the output module from where I take the signal out of the module into my recording interface. So if you go to the sample module, you can see the loaded sample. Same thing on the mSSP over here. So if you go to the module page here, here I have the LFO. I can go to the next module. I see the output module. So I see scopes for all the output signals. And here I'm on the sampler. And the sampler, you can do things like change the start and the length. So I can shift the start position for playback to here. I can change the length of playback like this. And again, you have 2 different colors, one for the left channel and one for the right channel. So now I have made the loop shorter. And now if I want, I can even do crossfading. So I have a crossfade feature. You can change the window of the crossfade to be shorter or longer or whatever. You can also tune the sample, change the tuning of the sample. Like that. And this value here for the tuning is actually the frequency at which the base frequency of that sample. So like if you load a sample, you can adjust it like this, if it's not 440 or whatever. So again, you can switch parameter groups like this, and now with the 4 encoders I can control the crossfade, the frequency, the tuning. If I press up, I can control the start and the length of the looping window. I can also zoom into the sample like this if I want to. I can do that too. Yeah, so pretty much you have the same kind of controls and the same graphical display as on the big SSP. If you want to load a different sample, then you just use the first encoder. So if I want to load this square sample, I just do that. Actually, I have to use not this, but I have to use this encoder here. So now I have this other sample, and I can change the start and the length if I want to, and do everything like that. Yeah, so that's how that works. Of course, you can still manually change the parameters of, for example, the filter or the LFO if you want. Here on the mSSP, I can go to the filter page and I can change the cutoff of the filter. You can play with the resonance. Envelope follower has a couple other parameters as well, like attack, release time, threshold, this kind of stuff. So yeah, same with the LFO here. Parameters like that. So output scopes. So again, yeah, you don't. So when we ship 50 patches with the mSSP, you don't actually have to edit those patches, or you don't even have to mess with all the individual module settings. We will provide macro settings at the global level, which will make it very easy to use. You can find the list of all the patches that we will provide on the Kickstarter page, and half of the patches you will have the possibility to vote on. So you can say, oh, I would like to have this patch, or I would rather have that patch, or whatever, and then we will take all the voting results and we will use that to decide which patches to build for the remaining 25. So go here to the next patch, pick SSP as well, and then so here we go to the model page, so we can go through all the modules, and we'll go through them over here as well. So basically, you have a patch where you have 3 pages with 4 oscillators each, and we are only using the sine wave output of those oscillators, even though you get 4 signals out of those oscillators simultaneously. So sine wave, sawtooth, square wave, triangle. We're only using the sine waves from those oscillators. So if you go through the grid here, this is the same thing again, and this is the same thing again over here. So you have 3 times 4 oscillators, plus 3 envelope generators, plus 3 bus modules, and the bus modules are basically used to feed signals across multiple pages in the patch, so you can basically patch any signal anywhere in the patch. You know, if you have 16 pages times 8 modules, that allows you to get anywhere. So for what I'm doing is per page I'm feeding the output of the 4 oscillators into a bus module, and so I do that 3 times, and then I take the signals from the bus module into the reverb module, and then from the reverb module to the output module where it comes out of the jacks. And so I also feed the step sequencer signals into the bus module, so I can drive the 4 times 3 oscillators and the 3 envelopes all from the same step sequencer basically. So in the step sequencer, we'll go there first. So you see here on the module page, I have the sequence going. You have the same display on the mSSP of that. So if you go to the modules, you'll find the step sequencer over here. There you go. And so you can change things like the tempo of the sequence, like this. You can slow it down a little bit. It has a clock division factor, there is a pattern length, and so on. There is also synchronization internally between the step sequencers. So if you have multiple step sequencers, you can synchronize them together. There's also MIDI syncing features. I'm still working on those a little bit, but it's already working. I have to add a few other things for that, and test it with other MIDI devices as well. So here, if you press, so this is actually a module that has a lot of parameter pages, because every page has 4 steps that you access. So you have, these are all pages you can step through with parameters being the steps. So you have 64 steps in the step sequencer, but of course you can, you know, limit the length of the sequence. You don't have to use those 64 steps, it's not necessary. So if I go here, I can also enable or disable the gate, because the step sequencer has a gate output as well as a pitch output. And so I can press this encoder, and now I've edited that step. And or I can press this encoder, I have this. If I press all of them, so now I have enabled all those 4 steps. If I want to go to the next page, enable another one, I can do it over there as well. There you go. So that's how the step sequencer works. So again, you can go to the next module like this. You can look at the output scopes. You know, you could like play with the parameters of the envelopes. So in the envelope generator, again, you have more than 4 parameters. If you press up and down, you'll see I can access the other parameters. So for example, here I have this sustain level that I can change by turning the encoders. I can also group envelopes together. So when you group envelopes, what happens is that when you turn a parameter of one envelope, you're actually going to change the same parameter across all the envelopes in the same group. So that makes it easy if you have multi-voice patches, for example, and you have all these envelopes and they're doing the same thing and you want to change the parameters of all the envelopes simultaneously. You just have to find one envelope, change the settings, and it will change across all the voices. So that's basically how this patch works. You have the step sequencer and sends its signals into a bus, and then all the oscillators, the sine wave oscillators, get their pitch signal from the bus module, and they get their amplitude from the envelope. And the envelope is triggered by the step sequencer. So the step sequencer sends a gate into the bus module, the envelope gets the gate from the bus module, and so on. So again, you can do all this editing on your computer, on your Mac or Windows computer. You will not need a big SSP or anything like that. We provide an editor with the mSSP, so you can do all the editing from your computer. So that's how that patch works. So if you want to mess in this patch with the ratios of the oscillators, you'd go to one of the oscillators that you want to edit, and then you change the ratio parameter, for example, just like I did in the demonstration video. We can find another one. Obviously, there is 12 oscillators, so if you would want to change the pitch of those 12 oscillators simultaneously with a macro, that's totally possible. You would put a macro module in the patch on the editor on your computer and then connect it to all the oscillators. So for example, here on the big SSP, I go here, I put the macro module, oops, sorry, and I patch it to the oscillators like that. Then I say, okay, macro 1 modulates the frequency of the oscillators. Then here I would go and enable the frequency modulation input. And now this module will modulate all the frequency inputs of those oscillators. When I go to the global page here and I change the macro value, it will change everywhere. Okay, so that's it for this patch. So now we go on to the next patch, which is a 8-voice wavetable synthesis patch with 3D morphing. So I will call up the patch both on the mSSP and on the big SSP so we can look at it. So we go to the global page, next patch, 8-voice wavetable oscillator, and then here on the global page in the big SSP, same thing. Out of the patch. Now we have the overview. So again, you'll have this editor on your computer. It's not finished yet, but you'll have it for Mac and Windows, and will work with the mSSP. So you have a real-time instant overview of all the patches, all the modules in the patch, and you'll be able to edit the parameters, add new modules, delete new modules, basically do everything in terms of patch editing that you'd normally do on the big SSP. Okay, so the way this patch works is that it has 8 voices, and every voice has a wavetable oscillator, an envelope generator, a MIDI module, and an input module, and then the output from the wavetable oscillators goes into a bus, like using a bus module, and then finally I take the sound out of the bus module into a delay module, and then from the delay module into a reverb module, and then to the output module. So the effects chain is actually right here on the first page. And this is also the first voice that you're looking at. So the input modules are used to modulate the X and the Y parameter of the wavetable oscillator. And of course, you can load wavetables on the mSSP just like you can on the big SSP. It doesn't matter. The big SSP here, you have a list, and you could like go through the files and load the one that you want. On the mSSP, same thing. You know, you'd go to the module page, you'll find the wavetable oscillator. You turn the selection encoder, and you can go through the list of all the files and load them, no problem. So here on the wavetable oscillator, if you turn the X, Y, and the Z parameters, you'll see the scope popping up for the X, Y, and the Z. So the wavetable oscillators, when they load a file, they actually cut the file into pieces, and you can then morph between those pieces in real time, in 3D. So you cut a file into 1,000 pieces, you'll have a 10 by 10 by 10 like matrix of waves in space, and you can morph between them. So it's like true 3D morphing. And you can change in how many pieces the file is cut using this encoder. You'll see the resulting wave that you'll be using here. And yeah, that's kind of how the wavetable oscillator works. You can also stack 4 oscillators per wavetable oscillator. So you could turn number of oscillators up. Goes up to 4, I think. Yeah, 4 is it. That's what it is right now. And then you also have a pitch spread parameter that you can use to spread those oscillators apart in pitch. So you can like make one oscillator really fat if you want. So I'll just go back and forth and reload the file so because I messed with the parameters right now. So there we go. We're back at the wavetable oscillator patch. And so I'm going to play this patch using a keyboard because that's how I set up the patch. And then I'll explain a little bit more about how the patch works here on the big SSP. So you can just plug in any MIDI controller into the mSSP over here in the port. And you'll get a notification. I still have to move this a little bit to the left in the software. But you get a notification that your keyboard is connected, and then you can start playing it. And yeah, so it sounds quite good. You can then start to do modulations using of the X and the Y if you want. I can take some cables. And I will plug it into my planar joystick from IntelliGel here. I take another one for the Y. Then we go over here to the mSSP, and I plug in these two. And I take the signals from the planar, the DC signals, into the mSSP, and in the patch, the signals come out of the input module here, and then they go into the wavetable oscillators. And I have multiple input modules, but you can have as many as you want. And this way you can feed the X and the Y signals to any of the XY inputs in the patch. Because yeah, we have 8 voices, so you have 8 wavetable oscillators. So the X and the Y is modulated across all the voices, basically. So when you play it, it sounds like this. So all these signals that we're feeding into the mSSP or the SSP are sampled at audio sample rates, so 48 kilohertz, 96 kilohertz, or 192 kilohertz, depending on what you want to use. And Yeah, so we're treating audio and CV signals exactly the same way. So obviously, instead of using a joystick, I could use like this this Dixie here. Could do that as well. Okay, so we'll take a quick look at the patch. Plug this back into the planner. And so in the patch, you have, per voice, you have the envelope. And then you have the bus module, already explained that. You have the input module where you can see, the signals from the planner. So it's connected to the mSSP, the planner. So you could go here and look at the input module, and when I move the joystick, you'll see the signals going up and down. So you have these scopes on the mSSP, just like you have on the big SSP, and they are everywhere, basically. Okay, so then we have the MIDI module, and the MIDI module basically takes the incoming MIDI notes and makes like a virtual CV signal, like a pitch signal out of it, and then you can send the pitch signal internally in the patch to the wavetable oscillators into their pitch input, or you could even send it out of the mSSP or the SSP, and you could control other modules with it. So SSP or mSSP also acts as a MIDI to CV converter, basically. And chances are we'll make a patch for the mSSP that we will provide as one of the 50 patches that we ship it with. That will be like a MIDI CV converter patch. You might already have a MIDI to CV converter patch, but maybe this will be useful in some situations. And then the MIDI module is also MPE compatible, so you get the typical MPE stuff out of it. You have velocity on, velocity off gate, you have aftertouch, you have all the typical MPE controls. So you could plug a Rolly Seaboard into this or an instrument, and it will work. So yeah, so here are all the voices. Like I said, there's 8 voices, so it takes a while to step through them. So this is a pretty big patch. You have 5 modules per voice times 8 voices, that's 40 modules, and then you have still the effects chain at the front as well. And so all those modules run simultaneously on the 4 processor cores. The processor is exactly the same between the big SSP and the micro SSP. It's a very powerful processor. Yeah, so that's how that works.